Hello everyone. In this video, we are going to discuss about predicting the alumina composites using machine learning and other techniques. This video is covering the abstract, introduction, contribution, methodology, and data sets and the functions and operations applied on those data sets, the performance and evaluation discussion, and finally the conclusion. So the abstract tells us that the machine learning techniques utilizes a Bayesian fine-tuned adaptive gated recurrent unit, which is used for forecasting the mechanical properties of the aluminium. Then training and testing are conducted on the data sets, which has undergone a comprehensive preparation process that includes a Z-score normalization. Then the principal component analysis is made use for a feature extraction that increases the accuracy and efficiency. And this study reveals that the Bayesian fine-tuned adaptive gated recurrent unit machine learning as a feasible strategy for enhancing the efficiency and sustainability in forecasting mechanical properties of aluminum alloys. So the alumina possesses an excellent mechanical properties and this is made use in the industries ranging from aerospace to biomedical engineering. So because of their unique strength, hardness and thermal stability, these alumina oxides composites are suitable for a wide range of applications. Then predicting mechanical property is essential for guaranteeing the dependability and the safety of the components composed of alumina composites. Then, in the mission critical situations, accurate predictions of mechanical properties of alumina composite might be a distinct between success and disaster, such as in aircraft applications where weight, strength, and thermal stability are essential elements. And the contributions stated in this paper is datasets for training and testings, then pre-processing of the data involved Z-score normalizations in order to clean and reduce the noise reduction. And using PCA is a critical step that reduces the dimensionality of the data. And the Bayesian algorithm, which has been proposed in this paper, is a powerful machine learning approach used in this study to forecast the mechanical characteristics of an aluminium alloys. The methodology involved data pre-processing, data cleaning, feature extraction, then predictions of the mechanical properties, and performance evaluation. So the data pre-processing involves Z-score normalization, and the data cleaning is used to resolve missing or incorrect values as a part of data pre-treatment procedure. In data cleaning, the data sets, data cleaning, and Z-score normalization is used for pre-processing. This feature extraction is done using the PCA. So the data set as given in this paper has a total 130 datasets were acquired from a material matching experiment. These datasets encompass various composition of aluminum alloys, yield the strength, hardness, and tensile strength of aluminum composites with matching values. To verify the integrity of the data, it entails evaluating it against predetermined rules and statistical criteria was taken down, and then data cleaning seeks to improve the accuracy and efficacy of the data driven decision making processes by methodologically so resolving these problems and producing a clean data set. So the main aim is to produce a clean data set, reducing all the noise and missing values, irrelevant values, or changing the data types of the few columns were all performed in order to gain the better results. So the Z-score normalization, which is commonly called as standardizations, was used to convert the numerical data to comply with the standard distribution. It includes dividing by the standard deviation after considering the data's mean. The values of the attribute B are standardized under their standard deviation and mean using the normalization approach. The following converts the value capital B to the B cap. So the formula is as follows here, where uh, each of the one of the term reflects the property standard deviation, and the mu of b shows the average value. The method works well in stationary environments because capital B's minimum and the maximum values are known. Feature extraction using principal component analysis. It takes a group of variables that are related to each other and transforms them into a least number of innovative parameters that are non-related to each other. For example, W is an input data where all column represents a sequence of m-dimensional inputs. Therefore, an orthogonal transformation Y can be employed to transfer the W to a novel space S, which is given as S is equal to Y into W. The first principal component analysis will possess the highest variance, indicating the most significant informations of the data. Predicting the mechanical properties of aluminum alloy using Bayesian fine-tuned adaptive gated recurrent unit, shortly known as BAGRU. So the Bayesian optimization is a technique utilized as a model-based hyperparameter tuning strategy. The Bayesian optimization records earlier assessments, minimizing unnecessary calculations for unfavorable hyperparameters. The proposed model incorporates the algorithm techniques to dynamically assemble module to achieve optimum hyperparameter tuning. The fine-tuned gated recurrent unit. The GRU is a simplified model with two gate functions, the update gate and then the reset gate. So the update gate determines how much previous information is preserved, and the reset gate will command the integration of past information with the current input. Performance evaluation and discussion. The mechanical properties of alumina composites are predicted by implementing the Bayesian gated recurrent unit algorithm in Python. So the adequate graphic processing unit, that is GPU, and a minimum of 8 GB RAM is needed for the experiment to educate the computer effectively. So this figure shows that the algorithm was able to produce a better fit uh, between the points and the regression line. Just one of the 13 points which differ dramatically from the regression line stand out as an outlier. Here is that point which is standing out as an outlier. The second figure shows that a closer examination of plot reveals that the residuals generated by this algorithm method is a better fits the data. This figure demonstrates that the algorithm method fits the regression line better when evaluating the yield strength, which suggests a higher correlation between the expected and the actual value. This figure shows that the actual and the predicted hardness values for the Bayesian algorithm are shown in this figure. 5 or so data points depart from the predicted fitting zone. Of them, 3 out of the 13 points do not match the regression line, making them stand out. The outliers display a notable divergence from the regression line, indicating a noteworthy departure from the overall pattern in the other data points. The paper was very successful prediction model for mechanical properties of the aluminium rod, such as tensile strength, hardness, and yield strength by using the machine learning, most especially the proposed algorithm in this paper, that is Bayesian adaptive gated recurrent unit. So this technique performs better at predictions because it uses the data for training and testing along with the careful preparation procedures which involved z-score normalization. So the principal component analysis was also made use for the feature extraction, and which was very much effective, and the metrics such as RMSE, that is root mean square, and the R squared showed a performance better than the conventional approaches. And the high level insights into the behavior of a material can be obtained by using sophisticated characterization methods such as imaging and in situ testing. Thank you for watching this video. Please do like.